Okay, this is an incredibly short lecture we're going to revisit 1 plus x to the 1/2 power and what is it supposed to be. I mean, the question here is I'm using a fractional exponent, and so and it arose simply by playing formal games. So we need to do some justification why it is what it is. And so recall that 1 plus x to the 1/2 is 1 plus 1/2 x minus 1/8 x plus 1/16 x cubed. As I should have said 1/8 x squared, 1/16 x cubed minus 5 128 x to the 4th, and then plus terms of higher degree. So anything that happens beyond this will have terms of degree higher than 4. Okay. And so I multiply it by itself. Okay. So 1 plus x to the 1/2 times 1 plus x to the 1/2, and we'd do 1 times 1 plus 1 times 1/2 plus 1/2 times 1 times x plus 1 times negative 1/8 plus 1/2 times 1/2 plus negative 1/8 times 1 plus x times x squared, and again 1 times 1/16 plus 1/2 times negative 1/8 times plus negative 1/8 times 1/2 plus 1/16 times 1, all times x cubed. And finally, because we don't have any more data, we'll stop with 1 times negative 5 1/28 plus 1/2 times 1/16 plus negative 1/8 times negative 1/8 plus 1/16 times 1/2 plus negative 5 over 1/28 times 1, all times x to the 4th, and then terms of degree higher than 5. When we do our simplification, this will leave us with 1 plus x plus terms of degree higher than 5. Okay. Are there any other terms? Well, we know that the terms for x squared, the coefficients of x squared, x cubed, x to the 4th, all fall out. So if there are any other terms, there are terms degree higher than 5, and so raising values close to 0 to the 5th power or the 6th power are going to be very small. Okay. So the idea here is that all of our other coefficients of all of our higher powers are actually 0. Okay. So my conjecture would be that for n greater than or equal to 2, 1/2 choose 0 times 1/2 choose n plus 1/2 choose 1 times 1/2 choose n minus 1, etc., going up this way, that you add all of these coefficients up, and that's equal to 0. You're welcome to try to prove that barehanded if you want to. Another conjecture, which is more powerful, okay, is that for real numbers alpha and beta, that the sum from k equals 0 to n of alpha choose k times beta choose n minus k adds up to alpha plus beta choose n. The idea here is that if I do 1 plus x to the alpha times 1 plus x to the beta, that it would be equal to 1 plus x to the alpha plus beta, and this would be the coefficients of such a thing. And so again, if we can prove this, conjecture 1, it would justify that, hey, this thing which we actually just got by playing with the math actually is real, and that in fact conjecture 2, that's again more evidence of that. So anyway, short lecture. Have a good one.